Every chip in your phone, computer, or AI system starts somewhere. Most people think it's just a factory with machines. But the truth is far stranger. There's one company quietly controlling the future of technology. You've probably never heard of it, yet without it, the world's most advanced chips simply couldn't exist. ASML, a Dutch company, makes machines so precise and complex that only a handful exist on the planet. These machines are the secret engines powering AI, quantum computing, and next-generation processors. So how does one company hold so much power over the devices we use every day? And what makes their machines almost impossible to copy? Stick around, because this story isn't what most people expect. ASML didn't start as a giant. In the early 1980s, it was a small optics company in the Netherlands, aiming to build the world's most advanced lithography machines, the tools that print circuits on silicon wafers. At first, progress was slow. The technology required precision at the atomic level, and mistakes could cost millions. Many thought it was impossible, but ASML persisted. Engineers invented ways to focus light so precisely that it could etch patterns smaller than a single virus. They combined lasers, mirrors, and robotics in a way no one else had attempted. By the 1990s, ASML had built a reputation for extreme precision and innovation. Chip makers around the world started noticing. Their machines could create smaller, faster, and more powerful chips than anyone else. Yet even with this breakthrough, it wasn't clear that ASML would dominate the future. Competitors were large, well-funded, and determined to catch up. And still, ASML kept moving forward, slowly but surely building the foundation for what would become an almost unchallenged position in the semiconductor world. What makes ASML so unique? It's their machines specifically, the EUV lithography systems. The EUV stands for extreme ultraviolet, a type of light far beyond what humans can see. These machines don't just print circuits, they etch patterns so tiny that millions of transistors fit on a single chip.
Which, by the way, will keep growing in average selling price as long as we can drive the cost per transistor down, which is exactly what we've been doing for the last 38 years.
The precision is mind-blowing. A single hair is thousands of times bigger than the lines these machines create. Creating this technology wasn't easy. Engineers had to invent new light sources, mirrors, and vacuum systems. Even the tiniest dust particle could ruin a chip. The machines combine lasers, mirrors, robotics, and software in a way no other company could replicate easily. ASML's machines are so complex that only a handful exist worldwide. Companies like TSMC, Samsung, and Intel rely on them for the most advanced processors. Without ASML, AI chips, high-end smartphones, and quantum processors wouldn't be possible. Yet, it's not just the complexity that makes ASML special, it's the network of knowledge and patents. Every machine comes from decades of research and experimentation, and ASML protects every piece of it. Copying it would take years, maybe decades. The bigger question, why hasn't anyone else caught up? Part of the answer is technical, but another part is strategic. ASML works closely with chip makers, understanding their needs, and continuously upgrading the machines. It's not just selling a tool, it's selling the future of technology itself. At first, it's hard to believe. How can one company control so much of the semiconductor world? The answer comes down to monopoly, scale, and timing. ASML doesn't just sell machines, they sell the only machines capable of producing the most advanced chips. That gives them an almost unchallenged position in the market. Companies that want the fastest, most powerful processors have no choice but to buy from ASML. Their machines aren't cheap. A single EUV system costs hundreds of millions of dollars. But chip makers are willing to pay because without them, they can't compete in AI, cloud computing, or high-performance devices.
This is where the biggest demand is. This is where the exponential curve is.
And it's not just the price. ASML's business model creates long-term contracts and close collaboration. Customers rely on ASML not only for machines but also for maintenance, updates, and technical support. This means predictable revenue for ASML and a high barrier for competitors. Then there's scale. Only a handful of EUV machines are produced each year, and demand is growing faster than supply. That scarcity combined with essential technology gives them unmatched pricing power. Another hidden factor is strategic partnerships. ASML works closely with governments and tech giants, getting access to resources, research, and cutting-edge ideas that keep them ahead. Yet the bigger story is influence. By controlling advanced chip manufacturing, ASML is quietly shaping the future of AI, computing, and electronics. Decisions about where, how, and when chips are produced ripple across the globe. The real question isn't just how profitable is ASML.
It still does blow my mind. I think even if you learn more about it, it blows your mind even more.
It's how is one company quietly deciding the pace of technological progress. Even a company as powerful as ASML faces hurdles. Nothing this complex comes without risk. First, there's geopolitics. ASML's machines are essential for the world's most advanced chips, but not every country can get them. Export rules, trade restrictions, and political tensions could slow or block sales. One misstep, and entire supply chains could be disrupted. Next is technical risk. EUV machines are delicate. A small error in alignment, a tiny defect in a mirror, or a malfunction in the laser could ruin an entire chip. Every system requires constant maintenance, upgrades, and highly trained engineers. Then there's competition, but not in the way most people think. Replicating ASML's technology is almost impossible. It would take decades, billions of dollars, and rare expertise. Supply chain challenges are another factor. ASML's machines rely on thousands of parts from dozens of suppliers worldwide. A delay or shortage anywhere could halt production. Finally, public perception and market dependency. ASML is so critical that any failure or scandal could ripple through tech companies, governments, and investors. The stakes are enormous. Yet despite all these challenges, ASML continues to grow. Each hurdle they overcome makes their position even stronger. AI systems far more powerful than today's. Quantum computers moving from labs to real-world use. Smartphones, cars, and devices running on chips smaller, faster, and smarter than anyone. ASML's machines are the engines behind this revolution. Every innovation in computing depends on their precision and scale. They're building the foundation for tomorrow's digital world. Consumer devices, medical equipment, and renewable energy systems all rely on advanced chips. ASML's impact touches nearly every corner of modern life. Yet, this future isn't guaranteed. Geopolitical tensions, supply chain issues, or a technical failure could slow progress. The company's next steps, expanding production, refining technology, and maintaining safety, will determine how fast the world moves into this next era. But the opportunity is enormous. With ASML leading the way, the pace of technological innovation could accelerate faster than most people expect. They are quietly shaping the devices, systems, and industries we'll rely on for decades. ASML may not be a household name, but its impact is undeniable. The company is the hidden force behind the chips powering AI, high-performance computing, and everyday devices. The story of ASML is one of vision, innovation, and persistence. From a small Dutch company to a global tech powerhouse, they have created machines no one else can match.
This is a monopoly right here and today. In the era of AI, there will be new vehicles for building semiconductors. And if I'm ASML, from any other company in this space, I'm being careful to make sure that I'm protecting my position, not just in the near term, but in the long term as well.
So next time you use a smartphone, a computer, or interact with AI, remember this: one company quietly controls the technology that makes it all possible. The future is being built today, one chip at a time, and ASML is at the heart of it. The question isn't whether their machines are impressive, it's whether we're ready for the world they're quietly shaping.